That's not necessary. So let's review. So, no. Oh, growl. No. Who chose that seat first? At this morning. You chose it this first. So you get dibs on it. So Brittany, if you don't want to have to move away from that area, I know you like that type of seat, you need to keep your pens put away. She can't handle the distraction of pens. That's her thing. She really likes it. And so, to be a good friend, you just need to keep them put away. You can use the one or two that you're using, but... Okay, so let's review. We said physical properties we've been talking about all year. But on TCAP, they're going to ask you to tell the difference between a physical property and a chemical property. And we said the way to do that, even if it's a property you've never heard of, or one you've not even thought much about, all you have to do is decide, if I want to see that property or measure it, do I have to change the matter? If I don't have to change the matter to see that property, it's a physical property. But if I do have to change the matter to observe that property or see it in action or measure it, it's a chemical property. We said the scientist's notebook has mass, it has color, it has weight, it has shape. You can measure those or observe those without changing the scientist's notebook. We also said that the scientist's notebook is what? Flammable. The only way for me to see its flammability is to do what? Catch it on fire. Now that'd be fun, wouldn't it? But Michigan would be happy with you at the end because you wouldn't have your scientist's notebook. The only way for you to see that flammability in action is to catch it on fire. And once you do that, the matter is now changed chemically. If you look, stay with me, Ethan. If you look, if you were able to analyze the ashes that remain, I need eyes. It wouldn't even be made out of the same stuff. It would be, the atoms have rearranged themselves. And some of the atoms would be gone where? In the air as gases. You've seen the smoke coming off of things as they burn. That's the matter. Some of that was matter that was in the thing you're burning. Some of it goes to a gas form and goes into the air. So far, so good? Are you with me? Now, there are lots of chemical properties, but what I want us to do is make a short list of chemical properties, the ones they are likely to use on a TCAP question. Some of these you already know about. You probably just didn't know that it was a chemical property. This one we just talked about, right? Flammability. Real exciting, right? After this, whatever that is that's burning, I can't even tell. After it's done burning, it's changed chemically. Can you get it back the way it was easily? No. Here's another one. Tarnish. Have you ever heard of tarnish before? Now, first of all, you recognize that picture in the top left. What is that, everyone? Statue of Liberty. Notice that there are two colors. Which one, the top or the bottom, is the one that you've seen most in your life? Drake. Yeah, the bottom one. If you go to New York City and see the Statue of Liberty, that's the way it's going to look. However, you may have learned in 4th grade that the Statue of Liberty was a gift to the U.S. from the country of France, and it's actually made of copper. So when it was brand new, it looked like this. So one of the things that copper does is it has a chemical property. That when copper is around water and oxygen, it will actually combine with the water and oxygen to form a material called tarnish. Now, I also have a picture of pennies there. You may remember when we did our experiment, some of you had pennies that had bluish green stuff on it. Did anybody have a penny like that? Yeah. Remember, pennies are made out of copper and zinc, and copper will tarnish when it's around water and oxygen. You know our pennies are around water a lot, right? So no wonder they have tarnish on them. But what happens is when the tarnish forms, that bluish green powdery stuff that's on it, it's made out of the copper, water, and oxygen. And that even if you clean the tarnish off a bit, after you remove the tarnish from it and make the penny look shiny and new, if you put it on a balance that was very sensitive, you would find that there's less copper there than there used to be. Some of that mass, some of that copper, went into making the tarnish. Now, one of the things that kids usually ask every year is like, well, we want the Statue of Liberty to look shiny and new. Why don't they just remove the tarnish like you do on pennies? They could, but it'd be a bad idea. Because one of the things that the tarnish does for the copper and the Statue of Liberty and things made out of copper is it actually protects it from further tarnish. If we scrub that Statue of Liberty off every time the tarnish got on it, eventually we lose more and more copper from it because some of the copper is gone and it's changed into the tarnish. Silver, real silver, actually does this too. Have you ever seen a piece of real silver before? When silver tarnishes, it reacts with the water and oxygen, just like copper does, but it makes a different looking tarnish. It's not blue, green, and powdery. It's black, a blackish gray color, and it feels real scratchy. Have you ever felt it before? And you can remove it. People that have real silverware or like a teapot or something like that, you can buy a silver cleaner that has probably I can't remember if it's an acid or base in it, and it'll remove the tarnish, but it's also removing some of the silver because this tarnish is made out of the oxygen in the air and the silver that's in the spoon. So even though it might look like it's the same, it's not the same anymore. Some of that silver was used to make the tarnish. Yes?
If there was something with tarnish on it, and you melted it down into a solid block, because the tarnish is made of only one metal, would it become the original metal again?
Well, if you had, let's say, this piece of silver, and it's got silver, but then some of the silver is combined with the oxygen in the air to make the tarnish. That's step to it. If you put the entire thing in something hot enough to melt it, I would think that probably the tarnish would float to the top.
Well, I thought this made because maybe the heat would.
And I'm not sure. I'm not sure if the temperature to melt it is hot enough to separate the elements that are in the tarnish, the silver and the oxygen, or whatever. That's a good question. I'm thinking though that probably it's less dense. It would float to the top, and they would probably strain it out, like pour the melted silver through a strainer, catch the tarnish, and let the pure silver go on through, so that way they would get out the impurities in it. That's a really good question. I'm not one that I'd have to do some research on that and find out. Because, that's interesting. So now let me ask you this: most of you said you'd seen this tarnish on silver or copper. Does every material have this chemical property? Can you think of a material, some matter, that doesn't tarnish? Brittany? Pencil. Yeah, I've never seen tarnish on a pencil. Have you? No, something else. Okay. Well, I've never seen tarnish on wood either. Lexi. Yeah, things that are plastic. Have you ever seen tarnish on plastic? Now, I've seen dirt and stuff get on it, but tarnish is when some of the atoms in the material combine with the atoms in the air to make a new material. And we can remove this material, which is part copper, part oxygen, part, other atoms. And we can remove it, but when we put that penny back on the balance, we're going to realize, a little bit of copper's not there anymore because it was combined to make this tarnished. And when we removed it, it took it with it. So, just like every single physical property doesn't go with every piece of, matter, like paper's not magnetic, right? Every single type of matter doesn't have every chemical property. Some things are flammable, some things aren't. Now, let me show you another one. I know you've seen this one. Rust. Another chemical property. Some materials will rust. Have you seen anything with rust on it before? Tell me something you've seen that had rust on it. Neela. Yeah, I have seen cars that have rusty spots on them. What else have you seen with rust on it? Zoe.
Barbed wire, actually. Yeah.
Barbed wire, is that what you said? What did you say? Yeah, I have too. I've done that too. Sometimes you have to get a tetanus shot too if you scratch yourself with something rusty. Kylie.
The fence
Oh yeah, so that the fencing there at the courtyard where the paints come off and you get the exposed metal, yeah. Katie. Yes, yes. So some things have this chemical property. Rust forms on certain metals, typically iron, and it combines with the water and oxygen in the air. And so the metal with the water and the oxygen form together to form a new material. And it has to be pretty warm. If it's too cold, rust has trouble forming. So it has to be like, the temperatures we have here on Earth. But you may have seen somebody remove rust from something. I have an iron skillet. Does any of your parents have iron skillets? One of the things when you when you get done with your iron skillet, when you clean it out, you have to make sure you dry it right away and put some sort of oil on it to protect it from the water and oxygen because it'll get rust on it. And rust is not something that just gets on it. That rust forms from the water and oxygen in the air and the iron in the skillet. And so then I have to get a steel wool pad and scrub the rust away. But every time I do that, some of the iron is gone. Yes, you might have seen a car that was so rusty that you could actually poke your finger through the rusty spots. Anybody seen? Yeah, my father-in-law used to have an old truck, and it was an old Chevy truck, and it ran really well, but the metal of it was really rusty. It was so rusty that the floorboard, where it had gotten water on it, you could see the road. Because what happens is every time it rusts, it takes some of that metal with it. And eventually it gets really thin. You can take a stick and just poke right through it. Have you ever touched the rust? Has anybody ever touched rust? How does it feel? Jenna? Yes, it's not very strong. Drake? Huh? Gritty, great word. Yeah, it feels kind of like sand. It's scratchy and crumbly. Gritty, Gritty is what he said. Zoe? Yes. What color is it? Yeah, it's reddish brown. So that's one of the things you can see here in this picture of that old train. You can see that thing's been sitting so long that probably the metal, there's less and less of that original metal there, and more of it's being used to make the rust, and it eventually will fall apart. We can take sandpaper and come along on this really strong chain. You see the chain there in the bottom picture? And we could sand the rust off. But if we keep letting it rust, every time it rusts, it's taking a little more than metal. And even though it might look like it hasn't been changed after we sand the rust away, it has. So if you put it back on the balance, you'd see some of that iron is gone. Now, so far we've talked about 3 chemical properties. Flammability was one. What's the other one we just talked about? Tarnish. And then the third one? Rust. Here's one more I want to show you. This one. Reactivity. Have you ever seen someone do that experiment before? It's not really an experiment, is it? It's really a demonstration. Has anybody done this at home or seen someone else do it? Can anybody explain what they're doing there and how they're making that happen? Gabe.
They have baking soda powder and they pour vinegar.
Yes, and so what happens when the baking soda and vinegar come in contact with each other?
It puffs up and just
Yes, and what are some of the, and so he said it kind of puffs up. And so one of the things that some kids like to do is they'll make a model of a volcano and to demonstrate how the lava might come out of the volcano, they put baking soda and vinegar in there because baking soda and vinegar have a chemical property that when they come in contact with each other, they'll react. So reactivity is another kind of chemical property. Some materials, when they get around other materials, something happens. Like the sodium and the chlorine gas, remember? They reacted, didn't they? When they reacted, what did it form? Do you remember? The sodium and the chlorine gas. Raven? Huh? I can't hear you. We saw the fire, but when it was done, what was left? Brittany? Salt was left. Do you think it would be easy to get that salt that was made in that demonstration back to the sodium and chlorine? Yes. Yeah, definitely. That's a chemical change, isn't it? The sodium and chlorine aren't the same anymore. They're still there, but they're not the same anymore. Now, so here's the next thing I want you to do. If you've got room on that same page, draw this T-chart. That what I'm going to put up. Wait a second. It's going to be short. If you've got at least a third of the page, you're good. So here's what I want you to draw. Put physical properties on one side, chemical on the other.
Can we start it by like PP and
No, we cannot. Okay, if you have at least a third of a page, you're good. There's only going to be about 4 or 5 things on either side. Don't put PP and CP because later on your brain will be like, what? Well, no, I don't have time. Well, I'll get it at the end. Yep. But, yeah, we are. No one's got this far yet. We're not talking about that. We'll get those in just a second. Now, I want to start over here. We just learned some properties that are chemical properties. What was one of the ones? Oh, this is getting on my nerves. Oh, I'm so tired of this not working. What was one? I'm going to type them instead of writing because what was one of the ones we just learned about, Neela? Huh? Yeah, so one of them is rust. Let me make a color that shows up. So we said one chemical property is rust. What's another one we've talked about today? Dakota? I can't hear you. Flammability. Let's write that. There's 2 M's in it. What does that mean? It's something has flammability. Dakota, what does it mean? Yes, it can go up in flames. That's why they say it's flammable. What was one of the other ones we talked about today? Katie? Yeah, and we're going to put reactivity. Some materials, when they come in contact with others, they react, and it makes new materials. So that's another chemical property. Vinegar reacts with baking soda. Oxygen reacts with about everything. And then what's the one we've not mentioned? There's one more. Statue of Liberty, penny, silver, all have this property. Britt? Tarnish, yes. Now, we have a very long and healthy list of physical properties, so we're just going to put a few on there. What's one physical property? Somebody give me one. Devin. Density. What's another one? Lexi. Malleability. Give me one more. Jenna. Buoyancy. And then you pick whatever one you want for the 4th one, and I'll get it. So put your own, because there's so many to choose from. You pick your own 4th one, and then I'll ask someone to share. What'd you put for the 4th one? What did you put for your 4th one? Somebody tell me. Gabe, what'd you put? Weight. Ashley? Color. Shape. Opacity. Color. So I'll just do color. So we know there's a big long list. We just want to have them for comparisons. So far so good?